In this video, we'll let you follow along as we develop this solution for our customer. In this container, we've cut right down the middle, reinforced the container, and actually have it as two halves now. So this customer is going to be able to take this unit, send it underground, it fits through their mine shaft, and they'll put her back together when it gets there. Stay tuned. For this job, container selection is pretty important. We want to make sure we get the same containers that we used in our engineered model. So two things that we look out for is up at the top, at the back, we want to have that 60 millimeter square tubing. And then on the sides, we want to make sure there's two different channel types. There's the what we call the regular C channel type, which is what we have here. And then there's also, we call it kind of an E channel type that has a bent recession that holds the wood floor, and that's what we don't want because it's a bit taller and our frame is designed for this style of a container. Prior to splitting the containers, we're just trying to get as much prep work as we can done. So the corner castings and the vertical posts, we're getting them all tacked together and then fully welded. These are very important welds. They're gonna get mag particle tested, so we need to make sure the boys do a good job on them. After this, we're gonna get the bottom channels all put together so that it can structurally support the floor. We've got the 20-foot floor channels all welded together, and you'll notice that we have these alignment dowels here at site underground. Once these two halves come together, one dowel will enter the other one, and then that'll allow the two halves to perfectly align and do that safely without anyone having to be, inside or between this container, making sure that they line up perfectly. Now that the vertical posts and the bottom channels are all welded up, we got to kind of make a game plan for cutting this container in half right down the center. And so we feel the best way to do it is we're going to take a wood skill saw and we're going to cut right down the center line and go through an inch of the 1 1/8" plywood. We'll follow back through that same hole with our metal cutting skill saw. And we're going to bury the blade as deep as we can, which is about 2.5 inches, and cut through all of the cross channels through the top portion of it. We'll grab this can, lift it up onto our modification beams where we can safely get underneath it, and we'll finish cutting all of the bottom floor channels. Now that we've cut through the floor outside of the shop, we've brought the container into the shop. We've temporarily supported the roof, and we're going to take our metal cutting skill saw and go through all the roof panels. We got to finish off the end wall as well. Once we have all the paneling cut, then we'll get to the final structural posts, just to finish off the 4 cuts, and then these two halves will be separated. Containers skid around on concrete or steel very well. One can use their skid steer or shop forklift to split the halves apart. One little problem that we encountered is we forgot to leave tolerance in the channel. So it's really tight trying to get this over the wood floor and under the cross members. So what we're gonna do is we kind of figured out we're going to router out a little strip here, material thickness, depth, and that's gonna allow us to now nicely fit this structural member over the wood floor. And then a perk with this solution is it's actually going to be nice and flush. So now, before where there was going to be the material thickness, which was a possible tripping hazard, now it's going to be perfectly flush. And then we have some inspiration screws here that we're going to find a wood thread, something similar to this, and then that's going to leave a nice flush finish again and no tripping hazard. We didn't have a solid plan in place on how exactly we were going to fit up the new structural kit and make sure everything lined up nice and square. We ended up tacking in the vertical posts, then manually lifting the headers in place, which proved to be difficult. After we finally got it all lined up, the final step was to weld everything solid. William used a come-along to pull the halves together, which was a slow and steady process, but it worked. We're going to be using our bolt-on bridge fittings. These have a regular thread and then a left-handed thread. So when you twist on the center bolt with a wrench, it brings both of the clamps in towards each other and locks these two castings together. Now these castings with this bridge fitting, they can still move up and down. Like this thing can twist one way or the other. And so that's what those dowel, alignment dowels in the floor, That'll help stop that with these coming together. If you're using these for other applications, you'd want to make sure that both the castings were sharing some sort of common foundation so that you're not getting uneven settling. And so that there's just a locking nut to make sure that nothing moves on you and just stuck in place now. The man doors for these containers are going to be installed underground. So because this is getting hoisted down the shaft, we don't want the door lever in the way and hitting anything on the way down. So we're just installing a structural frame for that man door to be lifted up in place underground and then riveted into. We have the 2 side posts already installed or tacked in place. We'll be doing the header across, and this is gonna be the right rough opening measurement for our dual swinger man door. So we're back in these split cans here. The engineers just left. We passed the Meg particle test with flying colors, so good job to my welders, they did great. And we did learn lots. The second one definitely went together better than the first. And it seems like there already is quite a bit of demand with other mines, at least locally, for splitting these cans in half and ramming them underground. So we're excited to get all the primed metal painted and then start working on strut lining these things, installing the new hose spool racks, and get the workbench all mounted up on the wall and see how it does. It's got to stand straight up and down and go down the mine shaft. So everything's got to be secured nicely to the walls in this thing. So we'll get started on that and keep you in tune while we go through that whole process.
The freedom and flexibility of a strut line container makes it so easy for us to custom develop solutions for all of our customers' problems.
We're just checking back in on this project. A lot has happened since I've last been in here and spoke. So the containers, they've been fully painted inside and out. It's this nice bright white, so it really reflects the light nicely inside of here. We've got them back from paint, so they're all painted, pulled them out of the shop. Now the electrician's working on strut lining the containers. They'll be going up the walls in different places on either side, because the side where the man door is, there's gonna be a real nice workbench here, and then the opposite side there is shelving and hose reel racks. So we'll follow that along as that happens. And then just one thing to note here is this header that we have that allows the 2 containers to span when they're separated. It's also designed to allow us to insert our strut channel in there. So with this can, they want lots of light in here. It's going underground. You might also notice in this container that it's raining in here. So it's 4 degrees out. We're getting a lot of temperature shifts between freezing temperatures at night and warm, sunny days throughout the day. So this is the reason why you need big air 45 vents. They really help circulate the air through a can. So it's just a side note on this project. It's interesting. We don't always see this condensation. It's the right time of year for this to happen. And so if you're noticing that in your container, big air 45 vents, that's the way to fix it.
We also love that once we build a custom shelf or rack for one person, it's now a part of our library and can be used in future projects.
So we've got this thing all buttoned up and ready to ship to the customer. We've torn it apart one last time just to give you guys a final walkthrough. And so here is our split 20-foot container. We kept both doors functional, so they operate just as normal, except for they operate independently. So one door now can be opened without the other, left or right. That's pretty cool. In here, we've strut lined both halves. Into the strut, we've bolted on a workbench here. We've given them 240 volt power for their equipment, and then also electrified the workbench. So we got 3 different plugs in this workbench. That's another neat option with this thing here. Then some pretty heavy duty engineer spec'd temporary transport posts. So these will be removed once this thing's underground and reassembled. So that's just to keep the thing nice and sturdy as it's being stood up and sent down the mine shaft. Then finally, our hose reel rack on this side. They got hydraulic hose spools hanging from here. And so this allowed us to use our modular interior systems, our pipe brackets, and then we've come up with the special hose reel rack retainer and the cross pipe, and that 2-inch diameter is going to fit through their hose spool. Then we jump over to the other side. This one has the wires all connected into this junction box. So each one of them have a bus bar, so to speak, where we can connect the two cans together. It's very simple. Everything's labeled, so the electricians shouldn't have a problem underground. And that'll allow, you know, if you turn a switch on in one can or the other, all the lights will come on. So everything's tied together, and they only need to send power into one half, but then they need to join the two. And that seems to be a pretty slick way that the electricians have come up with. So yeah, it's got the load center here with power coming in from the backside. That's all done at site underground. And then finally we get to our steel shelving. So underground, they don't want any wood shelving for fire hazards, things like that. So it's all galvanized, all purpose built for this job and engineered and stamped. So each one of these brackets are rated for 300 pounds. So each set of shelving can handle 900 pounds. Then the lighting and all the electrical, everything's piped in using the strut system. You can see where the man door is going to be. This we aren't installing until it gets down underground on site. It's pretty simple. It goes up in one piece. And so just to stop the door lever from getting sheared off as they're tipping this thing sideways and slaying it around. So yeah, they'll install this man door once it gets to site. And finally, just the flashing pieces, which are down here. So each container, we cap the ends just so that it's a closed off airspace. They'll seal up everything, and then up on top of the container, we also have some ridge caps, which just close everything off. And so when these two cans come together, there is a dowel, an alignment dowel on the one can and a receiver on the other, and then just two bolt holes up at the top that'll keep this thing nice and tight. And so once it is underground and they have it assembled, they will be able to handle this thing and drag it around as one unit. That right there is us cutting a 20-foot shipping container in half. If you enjoyed this video or found it informative, please give it a like. If you'd like to see more, please subscribe to our channel and ring that notification bell. And as always, check us out at tcg.ca. Hope you learned something.